So yesterday in class, briefly, we looked at prime numbers. Remember the game that we had around class, and composite numbers. So to remind ourselves of that, prime numbers, well, in order, they start at 2, then 3, then 5, then 7, then 11, and so on. And they're special numbers because they only have 2 factors. Oops. 2 factors. In other words, 2 numbers that multiply to give them. So, for instance, 2 can only be made by 2 times 1. 5 can only be made by 5 times 1. And there's the 2 factors. Okay, so they're prime numbers. Bella?
Mr. Collins, can you zoom in just a little bit?
No, I can't actually. Have you me pinned to your screen?
Like into the paper.
No, I can't. It's not possible. Pin me to the screen. Make sure I'm pinned. And you can put me at full screen. Okay. All right, so. They are prime numbers, and there's a lot of them. Composite numbers are then all the rest of the numbers. And we're going to look at a property of composite numbers, that they can always be found. Any number, any whole number can be found by multiplying only prime numbers together. Say that again. So any number, make sure this is in your notes. That's a whole number. So this should be in your notes. To find those numbers, those prime numbers like 2 and 5 and 3 and 7, we use a prime factor tree to find those factors. So remember, factors are numbers that multiply to give a number. Okay. Okay, so let's look at, first of all, a very quick example of just a prime number, just 2 prime numbers making a composite number. So 10, for example, can be made. Does anyone know what 2 prime numbers multiply to give 10?
2 and 5.
Yeah, 2 and 5, yes. 2 times 5. But it's not always just 2 numbers. For instance, 100, and type your answer into the chat, can be made by multiplying some prime numbers together. Does anyone know what prime numbers multiply to give 100? So type your answer in the chat this time. So 25 is not a prime number either. And either is 4. Only prime numbers. Yes, it can be made by 2 numbers, but remember, prime numbers. And there's more than 2 of them. No, 50 is also not a prime number, Cosima, so it's going to be something times something times something times something. don't even know what the somethings are. Not necessarily just two numbers, multiple numbers. Nobody's coming up with the answers. Well, here we go. Well, I know. Oh, Brady, you know the answer?
Maybe 5 times 2 times 5 times 2.
Hey, you got it. You got it. So, because we know 10 times 10 is 100, well then 2 times 5 times 2 times 5, because 10, that makes 10, and that makes 10, is 100. 10 times 10. So you can do it out. 2 times 5, 10, times 2,
I should have thought about that.
20, times 5, 20 times 5 is 100. So this works. But it's kind of hard to find these four numbers. Yes, Bella. Kind of hard to find these four numbers just by doing a list like this. So for instance, I'll give you an example. Here's 3,630. And it can be made up of 5 prime numbers. 1, 2, 3, 4, 5 multiplies. Now I'll give you 30 seconds. Can anyone come up with the 5 numbers? Not very easy.
Oh, I'm still working out.
Eva, you have a question?
No, I'm just still working it out.
Okay. Yeah, if you're working out, that's okay. I'm not going to give the answer yet. But it's definitely not easy to find these 5 numbers. And that's where we're going to use prime factor trees in a minute. But I'm giving you a second so you can even figure this out. What 5 numbers multiply to get 3,630? All right. Carlo, is that one of the numbers you think? 2? Is there any more? Close. So Carlo, remember, they have to be prime numbers. So yes, 2 is a prime number. 3,630 is not a prime number. 10 is not a prime number. And 1 is not a prime number. Asmara, why are you leaving? Type. Either send me an email or type it in the chat. Okay. Does anyone need more time to work on this? Anyone in the middle of working on it? I'll perhaps give you a hint. Okay, we're working on it.
No, I'm not. Sorry, I couldn't get it.
Okay. Yeah, so some of the numbers, 2 is one of the numbers, yeah. And 5 is one of the numbers. I kind of knew that because it ends in 0. And anything multiplied by 10. So there's got to be something to do with 10 in there. And 2 times 5 makes 10. So remember, I'm not using 10 anymore. I'm using its prime numbers. The other numbers, now those, Carlo is right. 3 is in there because you can probably see a lot of 3s going on here. 3 and 6 is 2 times 3 and 3. So 3 is another one of the numbers. After that, I'm kind of stumped. I'm not too sure. Well, I know what the answer is. It's actually 11 which is another prime number, and 11 again. And you can type that into your calculator if you have one and check. Maybe I'll do it here on screen. So let's have a little look. Okay, I have a different calculator than you guys, but same process. So what was this? 2 multiplied by 5, multiplied by 3, multiplied by 11, multiplied by 11. And there it is. 3,630. Oh, Nikita, you got it. Nice. Yeah, so I can write this a slightly different in order maybe. It's nicer to write maybe in order from smallest to biggest. Sometimes to do that. And maybe I could write 11 squared like that if I want to be fancy. But this is my answer. Okay. So the key thing here before I start doing the prime factor trees is that any number can be made by just multiplying prime numbers together. Prime numbers. Any non-prime number. 2, 5, 3, 11, 11. They're all prime numbers like we said yesterday in class. Okay. Let's now look at some prime factor trees. Now I'm sure you've done this. Some of you have done this before, but we will go over it again. So the key thing here is I'm going to write a number, and then at the end of one of these trees, I want to get one of these multiplications that make the number, a multiplication of only prime numbers. So that's what I'm trying to do. So let's look at maybe a rather easy example first. So the first one I'm going to do is 48. So 48, what would the question say? Find 48 as a product, which means multiply. If you don't know what product means, of its prime factors. So that's what a question might look like. Find 48, and if you can do this, type your answer in the chat. But I'm going to show you a method to do this. So I don't know how many prime numbers multiply to give 48, but I do know it can be written as a product of its prime factors. So I start with 48. Yes, please. I start with 48. So question and answer. Oh, I'll focus in a second. I start with 48. Put a circle around it. I want to make a tree. It's a bit like a Christmas tree, I suppose. I'm going to think of two numbers that I know that multiply to give 48. And it's an even number, so I know 2 times 24. No, that's 49, Nikita. 2 times 24 is 48. Maybe if I know it divides by 2, I can always half it. So 2 is one number, and it times 24. Okay, so what I've done is these two numbers multiply to give 48. So they combine back up to give 48. Okay, Nika. All right. Now, the interesting thing about the number 2 is it is prime. Isn't it? So I'm going to highlight it because I can't go any further. Why can't I go any further? I'll show you on a separate piece of paper, and I'll put that up again.
Prime.
Yeah, well, if you have the number 2 and you want to split it up into factors, it's 2 times 1. And 2 then here is 2 times 1. And this 2 is also 2 times 1 until infinity. And that's what happens with a prime number. So once I hit a prime number, I stop. But 24 is not prime, so I need to split it up again. Let's think 2 numbers to give 6, or to give 24. There's a lot of them. 6 and 4, 3 and 8, 2 and 24. Does it matter which 2 I use? No. I can use any of those. Let's do 3 and 8. So once again, these two numbers need to multiply to give the one above. That's why they're attached to it. Okay. 3 is prime. So I can highlight that. 3 is prime, but 8 is not, so I must continue. 8. I think you might have it, Nikita. 8 is 4 times 2. Okay. All right. Well, once again, I've hit another prime number, 2. That's why it's important we can recognize one when we see one. All right. Well, 2 can't be split up, but 4 can, and it is 2 times 2. And both of those are prime. So when both numbers are prime, we can stop. All branches have finished as primes, we can stop. That is the tree drawn. Now, how do I write my answer? Well, I just take all these numbers at the bottom of the tree that I've highlighted and write them in a row. So 2 times 2 times 2 times 2 times 3. So put them in order. It's always good to put them in order. Many 2's I have. Let's make sure I have them all. 1, 2, 3, 4 2's, and a 3. Or I can write it, if I want to be fancy, a 4-time multiplication of 2 is 2 to the power of 4, isn't it? And that's another way of writing the same thing. And that's my answer. And you can check that in the calculator. Two times 2 times 2 times 2 times 3. Yeah, that's 48. Nice. Or, if I want to be fancy, I can write 2 to the power of 4 and then multiply it by 3. And that's still 48. Okay. So that is our example of prime factor trees. So hopefully that makes sense. To recap, when you get your number, just think of 2 things that multiply to give the number above. Always. If one of them is prime, you can stop on that little branch of the tree. So I'm sure you've done it before. Okay. All right, I want you guys to try now. All right, so I'm going to put green questions, yellow questions, and blue questions. 2 of each. So, question 1, question 2. Hopefully that table makes sense. If you do green, do these 2, yellow these 2, and blue these 2. I'll just take the numbers off screen for a second, and then I'm going to let you go.
Mr. Collins, you're muted.
I know.
Oh, sorry. And Eva's computer died.
All right, so let me just move the page up. Oh, I managed to make a mess of one of the ones in blue. Okay, so here are your questions. Green, I want you to do prime factor tree for 30 and 50. Yellow, 240 and 380. And for blue, you can read those numbers. That's a 7. It's a 7. No, just do 2. So pick your color you would like to try. Green, yellow, or blue. I'm going to start to do. So these I'll check in your book when I see your book on Friday. So I suppose it's homework for Friday.
Two of them, right?
Quentin, you have a question?
Right.
Oh, I missed that. Can you type in the chat? I just can't hear you.
Okay.
So just do any two. So you can do both green, both yellow, both blue, and that's you covered. Or if you want to try one green, one yellow, that's okay too. Up to you. You can do more than two if you have time. Definitely do more than two. Now we check your answers. Well, I think next time I see your book will be Friday, but I need you to do them now. For green, I'm just going to start off the two green ones. If you're struggling how to get started. Okay, I'll just start them on this piece of paper below when it focuses. These are the green. So start with 30. I think of two numbers that multiply to give 30. And I can go 2 and 15, or I can go 6, 5, 3 and 10. Okay, maybe we go 6 and 5. 6 times 5 is 30. Now,
if we finish green, can you do yellow?
yeah, minimum 2, not only 2. 2 is the minimum I want to see in your book. So if you've done green, green should be quite quick, and I'm gonna pretty much start them. So do either yellow or blue. Might be fun to try one of the blue ones. See can you crack that code. If anyone gets a blue one, do type your answer in the chat. Okay, so I'm doing this green one. Okay, so 5 is one of our prime numbers. So I can stop that one. And you can finish this by thinking, right, 6 is made by multiplying what and what. And there only is 2 numbers left, and they are both prime. And that'll be the end of the green one. And there should, underneath then, write something times something times something is the answer, and that will give 30. If you're doing green and not sure how to do the first one.
For that, can we get different answers?
Your final answer will be the same.
Oh, okay.
You can have different factors here, so you can use 2 and 15 or 3 times 10, but you will end up with the same answer.
Okay.
Yeah, no problem, Bella.
Okay, Mr. Collins, we did it together, but I'm just double checking. So we have 30, and then we did 2 and 15. 2 is a prime number, so 15 is 3 and 5, so it just stops there.
For the first one in green?
Yeah.
Okay, yeah, so anywhere, so this one, well, 2 and 3 is here, yes, and so hopefully if you do green, you have this one finished. And then I just write 2 times 3 times 5, because these two are both prime, so if you're using the highlighter like me, you will say, oh, they're both prime, and you would highlight them, and then I have nothing else to split up.
So that's the end?
That's the end, it's done.
And so the answer is
2 times 3 times 5.
Oh, okay.
It is.
Okay,
Yeah.
thanks.
So that's the first one done in green, so try and do the second yourself. Quentin, no decimals, they have to be prime numbers. So if you end in a decimal, you've got something wrong. Go back and check. That's why the blue ones are so difficult, because they're hard to find two things that multiply to give the numbers. But if you're doing blue, I'll give you a hint. The first one, start by dividing by 10 maybe, because I know it ends in 0. And the second one, divide by 5, because it ends in 5.
Once we finish, is that done for like